Hello friends, welcome back to the lecture series on engineering mathematics. In today's session we are going to discuss about indeterminate forms. In previous few modules we have discussed about indeterminate forms, 0 upon 0, infinity upon infinity, then 0 into infinity. In today's session we are going to discuss the indeterminate form infinity minus infinity, 1 raised to infinity, 0 raised to 0 and infinity raised to 0. So let's recall, to evaluate this indeterminate form 0 upon 0 we used to apply the Lopital rule or L'Hospital rule. Then we have discussed, to solve this indeterminate form 0 into infinity, method of solving is we used to convert this function giving indeterminate form 0 into infinity in terms of 0 upon 0 or infinity upon infinity by using some adjustments and then apply the L'Hopital rule. Now the similar kind of adjustment we are going to deal with this indeterminate form. So for solving infinity minus infinity indeterminate form, we consider one function f of x which tends to infinity as well as g of x tends to infinity as x tends to a, and the given functions are of the form f of x minus g of x as limit x tends to some function a. So for solving this we use the adjustment. So here we are getting the indeterminate form infinity minus infinity. So we can rewrite it as 1 upon some function of x minus 1 upon some function g dash of x. To avoid the confusion with g dash representing the derivative, we consider f star and g star in the denominators. So as f of x tends to infinity, 1 upon f star will tend to 0 and this will tend to 0. Then we take the LCM and we try to rewrite this function as g star of x minus f star of x will be the part of numerator and denominator will be f star of x into g star of x. Now if you observe, g star of x tends to 0 minus f star of x tends to 0 as x tends to a and denominator will be 0. So this is the indeterminate form 0 upon 0, and now we can apply L'Hopital rule to evaluate this limit. Evaluate the limit of the function sec x minus tan x as x tends to pi by 2. So for solving this problem, we consider let L be the required limit of the function limit of sec x minus tan x as x tends to pi by 2. If you substitute the limits here, sec pi by 2 is nothing but 1 upon cos pi by 2 and cos pi by 2 is 0. 1 upon 0 is nothing but infinity minus tan pi by 2 is infinity. So we are getting indeterminate form infinity minus infinity. So for simplifying this, we need to convert this function in 0 upon 0 or infinity upon infinity form. So we can rewrite sec as 1 upon cos x and tan can be written as sin x upon cos x. We can consider the common denominator here. As limit x tends to pi by 2, we can rewrite this function as 1 minus sine x in the numerator and denominator term will be cos x. Now if you substitute the limits, sin pi by 2 is 1, 1 minus 1 will give you 0 in the numerator, and cos pi by 2 is 0, it will appear in the denominator. So here our indeterminate form is 0 upon 0. Now we can apply the Lopital rule here. So by applying the Lopital rule, we get derivative of numerator in the numerator as, so derivative of sin x will be x, and derivative of cos x is minus sin x. Now we substitute the limits, as x tends to pi by 2, cos pi by 2 is 0 in the numerator and sin pi by 2 is 1 in the denominator, so this value is equal to 0. So conclusion is required limit is 0. So in this way, for evaluating the indeterminate form infinity minus infinity, we just need to use the adjustment so that the given function can be converted in terms of 0 upon 0 or infinity upon infinity for evaluation. I hope you have understood this.